Yes, can you hear my voice?
Yes, we can.
Good afternoon, everyone. So today, Angela and I will talk about fabric-based PCR microfluidic chamber for DNA amplification. That is from the semester 6 project, previous semester 6 project. So first, I will discuss about what is PCR actually. The definition of PCR itself is that PCR or polymerase chain reaction is a technique that defined for replication specific DNA fragments from small amount of sample to large number of sequences. So for the PCR to happen, there are three steps that need to be underwent. So the first one is denaturating, annealing, and extension process. So for the denaturation process, it needs temperatures, which is 95 to 98 degrees Celsius. So in the denaturation process, the DNA is still in double-stranded DNA. So in this process, they will break the strand to become single DNA strand. And then after that, they will go to the annealing process. In the annealing process, they need temperature between 50 to 65 degrees Celsius. It depends on the primer. So in annealing process is the process where the primer will bind to the single strand DNA. And then the temperatures is really determine the result of the product. So if it is too low, the primer cannot bind perfectly, but if the temperature is too high, it will not bind at all. So what they usually do is they use the temperature 3 to 5 degrees Celsius below the melting point of the primer itself. And then after that, they will undergo the extension process. In the extension process, it needs 75 to 80 degrees Celsius. So the primer can extend using the TAQ polymerase. It is an enzyme. So they use that kind of process to extend the primer to become double-strand DNA again. So this process the DNA will be multiplied again and again and again from each cycles. And these are the requirements that the PCR needs. It needs thermocycler, TAQ polymerase, primers, the NPP, and also magnesium 2+. And without this, the PCR cannot happen. And because the project is made when the COVID-19 is happening, so to detect COVID-19, they use qPCR or real-time PCR. Actually, there are a lot of types of PCR, but for the specific, they use qPCR because it facilitates the analysis that provide real-time detection of the products during exponential phase. So the result is already there.
This device also uses the microfluidics concept. The microfluidic concept is defined as the behavior of fluid in a very small scale. Because it is behavior of fluids in a very small scale, it means that only a small volume of sample is needed for this device. And it relies on capillary forces to control the flow of the fluid. And an example of the microfluidic system can also be seen in point-of-care applications, drugs administration, simulated organs on a chip, lab on a chip, and etc. Next.
I'm sorry. So in this paper, our seniors propose the designs and the solution. So the first thing that they propose is related to the chamber. They use this kind of equation, which is energy is equals to mass times C times delta T, and power times time, and also for the mass, it equals to the density times volumes. And they arrange it again, and they found that delta T is like this kind of formula. So they conclude that delta T is inversely proportional to the volume. So when the volume is small, the delta T will be large. Therefore, they want to create something that have smaller volume than the tubes that is usually be used in the PCR test. So what they made is this kind of chamber, which is made of hydrophobic and hydrophilic properties. So the hydrophilic part is made from fiber, but the hydrophobic part use epoxy resin. So what they do is they wait a minute. Can you see my mouse? Or no? Hello?
Little bit small.
Okay, so what they do is like they will fold the number 1 to the number 2 to create cover for the number 2. They will put the sample to the number 2, like here, because it's the hydrophilic part. So of course the fiber will absorb the sample, and then the sample will stay there because around it's a hydrophobic properties. And after that, this is the place where the PBS is put to determine the sample after the PCR is done. And these are the electrodes. However, the seniors did not make any thing for the electrode because they really focus on the heater and also for the sensor itself. Okay. Next, when we talk about the heater and also the sensors and the casing, so they use, for the heater, they use mono-walled carbon nanotubes, CNT, as thread, or and they also use an alternative alternative materials, which is nichrome wire. And for the sensor, they also use MWCNT thread also. And for the casing, the volume of the casing they design is 120 times 120 times 70 millimeter. So the reason why they built the sensor and the heater like this shape is because meter shape like this is because to maximize the properties, so maximize the heat and maximize the sensor itself. So when they combine it with the chamber, these are the these are the design that they propose. The first layer will be combined to the second layer. The second layer is totally in the hydrophobic part, so the sample will not go anywhere. And then they in the third layer there will be CNT thermistor, and the fourth layer will be nichrome wire heater. So these are the design. And next is the experiment. So to create the fabrication of microfluidic chamber, the first thing first is they design it in the Silhouette Studio software, and then after that they print it in the self-adhesive vinyl paper as the template, and then they will create the resin, epoxy resin, which is resin solution and also resin hardening with the ratio of 1 and 1. And after that they will dry it for 4 hours, and they have to test it because some of the properties of the epoxy cannot stand with heat. So they test it with oven in the 95 degrees Celsius for 2 minutes. Why 95 degrees Celsius is because as I mentioned before, the denaturating process use 95 degrees Celsius. And then next is the electrical, is the electrical circuit to control temperature. So these are the circuits that they propose to control which time should they decrease the temperature or should it increase again. So they also use the what's it called, the code like this. So they use relay, and relay is acts like switch. So when it is the denaturating part, the relay will not turn on, and after that it will turn on. So it's basically it's like a switch. And then next, I will go fast to this. Yeah, this is the code also. And yeah, so they use to convert resistance from sensor to temperature. They use a Steinhardt and Hart equation. So these are the Steinhardt equation, and they compare it to three what is it called? Three temperature, which is 60, 80, and 100, because that is the range of the PCR as a temperature. So they do this is to find the constants A, B, and C. So, and the A, B, C will be inputted to the program, and the program will process to convert the resistance to the temperature. And then for the carbon nanotubes as heater, they do an experiment like this. So these are the CNT thread. They use PCB, crocodile clips, and also the CNT thread, and also the head pin. And they loop the like this. They will loop the thread parallelly to each other to the neighboring, and then after that at the back they will connect one side of the pin to another side of the pin, so they create a series circuit, and then they test it. They use two multimeters to test the voltage and also test the current that is flown, and they also use IR thermometer as the standard to measure the heat that is produced from the carbon nanotubes, like that. And the last one is the carbon nanotubes as sensor test. So to test it, they use one carbon nanotube thread, and they also use crocodile clips and copper plates. So they lie the thread into the hot plate. This is the hot plate, and after that they wait for 30 minutes, and they record the track. So they use as a standard is mercury thermometer. So yeah, and finally they can track whether the sensor can be whether the CNT can be censored or not.
Next, we are going to talk about the results of the previous experiment. First of all, this the use of epoxy resin as fabric base chamber and hydrophobic layer. After it undergoes the oven heating test that Ezra has previously explained, they prove that they can withstand up to 95 degrees Celsius, which means that it is a suitable material for the fabric base chamber. As for the CNT coated thread as heater, as temperature increases over time, the resistance decreases and current increases. However, the highest temperature recorded that can be reached is only 75 degrees Celsius with voltage 34.2 volts and current 101.6 milliampere before it showed signs of burning and smoke. So we can conclude that it is not a suitable material for the heater as it burned before reaching the desired temperature and that they may contaminate the sample. Next is the use of CNT-coated thread as temperature sensor. The results is shown in the graph on the left side. The temperature changes causes resistance of the CNT sensor to change as well. However, the experiment shows inaccurate reading because the change in CNT sensor is very quick and the mercury thermometer cannot keep up with it, so the measurement in it is not as accurate as the change in the resistance. Other possible causes of error is also environmental factor, which is heat loss to the environment because of the position of the thermometer's depth, and it can also be from the hot plate itself. Okay, next is the electric circuit to control temperature. From the calculations of the Steinhart equation, the constants obtained are A equals to minus 3,936.696123 times 10 to the power of minus 3. Constant B has a value of 6,131.540302 times 10 to the power of minus 4. And constant C has a value of minus 22,002.84881 times 10 to the power of minus 7. The Arduino IDE code itself is suitable for maintaining the temperature. However, the Steinhart equation is not suitable for use in this system because when we try to convert resistance to temperature using online Steinhart calculator, it does not give the expected temperature, which is maybe caused by the lack of calibration or the ever-changing resistance of CNT sensor. Next, plans for further improvements. First, about the fabric base chamber. We will first focus on the construction of the fabric base chamber and compare the results of the manufactured PCR to commercial PCR machines results, so that we know if the chamber is successful as a PCR machine or not. Then for the CNT heater, the thread, we will try to use another fiber to construct the thread that will hopefully produce less resistance. If that is also not successful, we will try using CNT sheet instead of thread. For the CNT sensor, since the reading is inaccurate because of the fluctuating resistance, we will try to put the sensor in a fixed position. For example, we'll swing it onto a cotton fiber so that it becomes more fixed in order to reduce the wavering of the resistance value. Alternative material, if CNT thread and sheet are not successful as the heating element, then we will try to use a new material, which is a iron chromium alloy, iron chromium and aluminum alloy called Kanto as the heating element. We choose this material because it has similar properties to the previous alternative material, which is nichrome wire. Conclusion. So for conclusions, the fabric-based chamber, the epoxy resin is a suitable material since it can withstand heat up to 95 degrees Celsius. As for CNT heater, it combusts at around 75 degrees Celsius, which means that the resistance needs to be reduced so that current will increase and reach required temperature without increasing voltage that may cause overheating. For CNT sensor, it is functioning but inaccurate, and it will need calibration to improve the reading. Other plans to improve the include calibrating resistance reading process, using CNT sheet instead of thread, and as I've mentioned before, using a different material to construct the CNT thread. And yeah, that is all from us. Thank you.
Okay, thank you, Anjali and Ezra. Please group 2 ask questions, Andy and or Tanita, and please turn on your video when you ask questions.
Sorry. You mentioned before about the lack of calibration. So how do you plan on overcoming it? Yang ada di slide sebelum-sebelum.
So we discussed it to Samuel Andrew, and he said that actually the calibration is really hard. He compared it with sensors, IR sensors, and also the LM. I forgot the LM part, but actually the calibration that he inputted in the paper is not as accurate as the other experiment that he did, but he did not put it in the paper. So maybe we can try to use that kind of calibration method that he already do, because he said that the method is more accurate than the one in the paper, like that.
Okay.
Anjali, kalau ada tambahan?
Nggak ada tambahan sih, udah semua.
Okay. Andy, do you have any question?
Andy?
Andy, ada question? No question, Andy? Okay, so I have question. So why what is wrong with Nichrome? Why you are proposing Cantal? Because I think it will be more difficult again to have that Cantal in terms of maybe also more expensive. Why don't we stick to either CNT coated thread heater or Nichrome heater?
For Nichrome itself, they already tried it, and it can reach 95 degrees Celsius, but when it cooled down for the annealing process temperature, which is around 65 degrees, it causes the jumper cables to melt. So it's not very, I think they meant that it's not very good at.
This is what? This which heater?
Sorry, sir?
Using which heater?
The Nichrome wire.
Why is the jumper cable mild? Do you know what the cause?
So it melts when it is cooled down from 95 to 65, possibly because it cannot withstand the change.
Yeah, can you find out why? Because maybe you can have a current limiter circuit or something else. Yeah. Because if I don't think it is the material that causes such problem, the jumper wire melt. Yeah, maybe because the jumper wire itself has resistance. Yeah, and the current is already over its limitation. And then it can be simply solved by using a thicker jumper wire rather than changing the heater at all. So please be more critical in assessing. Even them, their reports are not maybe 100% accurate, you have to be critical as well to their report. And they are not yet finished. It's why a lot of holes in their reports.
Yeah. Okay.
Do not consider all their what they wrote is correct.
Okay, sir.
Okay, sir.
Okay, if no more questions, that will be all from me. So please investigate further. And next milestone, please be more already apa namanya? Keep it really practical implementation. What steps do you plan to do? Yeah, etc. And the timeline as well. And I don't mind if you already start to purchase the necessary material. If please ask Kak Devita whether some of the materials are still there, left over from the previous biomedical instrumentation group, the semester 6 students. If not, then please order it as soon as possible. That's why I'm a bit reluctant to use a new Kantal, for example, as heating element, then it will require a new purchase. It's not about the cost usually, which is more critical, but the time. It may take some time for it to be ordered and purchased. You don't know if this Kantal is easily available or not.
Okay, sir. So we can try it from now.
Yes, you can already try for now. Not necessarily you have to wait until the later weeks. Yeah, so you can already try some, but yeah, I need the further improvement. I need to have more to the point and more clearer. Yeah, because maybe your writing there further improvement is a bit too fake and too wide. Be more specific and put it in your report to be more specific. And for example, the CNT coated heater, what will you do about that? What you can do in the CNT coated heater itself is a problem. I understand that compared to nichrome. Nichrome has small resistance. CNT coated heater has higher resistance. What we can do is if we insist in using CNT coated heater, you need to reduce the resistance. How to reduce the resistance? You can ask Elga because she did certain technique to have braided CNT coated thread while she was also doing sensor and measurement project 2 years ago, I think. Otherwise, yeah, we can try first nichrome as the heater and CNT coated thread as the thermistor as the sensor. And please be careful with the calibration of the CNT coated thread as the thermistor, as the resistor. Yeah, I'm not sure if their calibration method is correct already. The group, that semester 6 group. Yeah, because the slope is so apa namanya, landai in English. Steep, the opposite of steep. Shallow, yeah, shallow. It should be steeper, yeah, in order to increase the sensitivity. So please have a thought on that. Okay, thank you very much, Group 1. Let's proceed to Group 2. Yes, you may proceed as you are ready.
Okay, so good morning, Pa Dedi. Good morning, friends. So for today, me, Andy, and Tanita, Grace will present about the contactless temperature sensor based on CNT coated thread IR absorber that was researched by our upperclassmen. So there are two main contents. The first one is the review on previous work, and the second one is the current purposed device. So for introduction, infection at body can create symptoms like fever, and it is usually caused by virus. And one an example of disease is COVID-19, and COVID-19 has have symptoms of fever, and to detect fever, the device that could measure temperature is needed. But due to uh, the ability to infect people from droplets uh, will be bad for an active temperature sensor. So it would be better if we use a passive temperature sensor, such as infrared sensor. Carbon nanotubes that was discovered by Ijima at 1991. Uh, it has properties. It have properties like electrical, mechanical, and thermal properties. And on the previous study by Gokale et al., they dispersed the CNT in a polymer and resulting thin film near and short wavelength infrared absorbers, and they reached uh, a really high value of infrared absorption, which is up to 95%. So from this, we can actually take the advantage of it to make sensor. For the basic principle, a human body can emit heat that can be measured in range of electromagnetic spectrum. In that spectrum, our body heat wavelength lies between the microwave and visible light, which is mid range, mid infrared range, and we can calculate the spectrum radiation using Wien's law formula, where where B where B is Wien's displacement and T is the temperature. And for bolometer, the bolometer is a device that used to detect heat and measure thermal radiation using a temperature sensitive resistive element that when the resistance change, uh, when the temperature change, the resistance will also change. The circuit of the bolometer will be used, that is used is the Wheatstone bridge circuit. Uh, and it is a temperature sensitive resistor, yeah, as I said before. And when the uh, when the when the when the heat when the heat change the when the temperature change, yeah, the resistance will also change. And for the review on previous work, uh, as for the material fabrication and measurement, these are the main materials, like MCW and TCOOH. Uh, it will be used as a thermistor. Uh, to be exact, in NTC thermistor, and it is it is a resistor that a negative value that with a negative value temperature coefficient. So when the resistance decreases, so when the temperature increases, the temperature So when the temperature increases, the resistance decreases. And for the HBN, it will be act as the IR absorber, which could help the sensor to absorb IR more. The PLA plus will be act as the casing, and it will be a thermal isolators, so that the bolometer can have a better value. For the Brayfric, it will be a platform for the thermistor. The ZNSE lens will be an inlet of the bolometer placed between the infrared and the sensor. And for the Arduino, it will be a microcontroller to detect the temperature, to measure the temperature. So for the materials quality, for MCWNTCOH, it conduct heat electricity. It has a thermistor NTC, which I was said, as I said before, that when the temperature increase, the resistance decreased. And why using MCWNTCOH? The COH actually can bind the oxygen, and making the fabric stronger. For the HBN, it absorbs the infrared. It is thermal conductivity and stability, and it will not affect the resistance of the thermistor. For the PLA, it will not conduct heat, because if it conduct heat, it will disturb sensing the sensing temperature. As for the uh, as for the zinc selenium lens, it can it can it can make the IR range wavelength go through. As for the fabrication steps, the first one will be making the thermistor by firstly coating the fabric with HBN and sewing MCWNT-COOH thread in minder arrangement. As for the second step, it is to create the thermal isolator. PLA plus was used as the material of the 3D printer thermal isolator for the casing of the device. The third step is to put together all those parts that were made to make a bolometer. The inner and outer casing will be covered by aluminum foil, the HBN coated fabric, then placed below the lens and glued between the openings of the casing, and attach wires. Both ends of the thread connect with the thermistor, and put the ZNSE lens on the inlet of the casing, and attach a straw for the vacuum. Lastly, integrating the thermistor to with Stonebridge and Arduino.
So first is the fabric coating. First, HBM from the hexagonal boronitride. Boronitride is extract. After that, the extraction is mixed with distilled water, and then exfoliation is done under sonification. It will then produce suspension. The suspension is then centrifuged, and then from the after the centrifugation, extraction of the supernatant and residue was done. So I think Kasem Andrew test whether the supernatant or the residue one has a could produce a better quality, and he proved that the residue one could produce a better resistance sensitivity. So that's why the residue was used to coat the cotton fabric. And then next is weaving the thermistor. So this is the arrangement of the MWC and COOH. This was provided in the lab before, then I think it was done by previous work. It was done, yeah, it was made previously. So yeah, they didn't make this, and then this is staged in minder arrangement to improve sensitivity, and this was proven in previous reports. And this is the picture of the woven thread. Next. Next is creating the thermal isolator or the bolometer casing. This is the top part and this is the bottom part. So it could be there are two parts and they will be attached like that. And they were made using PLA plus. Next. So this one I think Andy has explained it before. This is the IR lens, the zinc selenium lens, and then the fabric, the HBN coated fabric, and the thermistor which was knitted onto it. It was attached in between the top and bottom casing. And then there were also aluminum foils here and on the internal and the external part. Why? Because for the internal part, it is used to reflect the infrared light so that it could fall here. And then for the external part, it was to deflect other electromagnetic wavelength. Next. And then as for the measurement steps, the thermistor the thermistor resistance will change when the temperature increase or decrease. And then the change will then produce a voltage difference in the whetstone bridge, which will be explained later. And then the analog voltage signal will be sent to the Arduino. The voltage will then be converted to the thermistor resistance value. And then from a formula, temperature could be obtained from the resistance value. Next. This is the whetstone bridge that was planned to be used, but they didn't reach this step. Whetstone bridge is actually a null measurement method. This is the thermistor that will be that was connected to the whetstone bridge, and this is the voltage difference that will be measured between V2 and V1. So if, for example, the what is it called? Oh, the resistance decrease. Then the voltage will also decrease. Then if this voltage decrease, then this voltage, the voltage here will increase, and yeah, this one will be bigger than V1. Yeah, this happen because both sides should have a stable voltage of Vs, because it is it could also be said that this circuit is in parallel. Next. And then this is the formula for the RT calculation, the thermistor resistance calculation, and this is the derivation from this formula. Next. And then Andy has also mentioned before that the MWCNT is a NTC type of thermistor which is non-linear and is inversely proportional. So the NTC type of thermistor, they have their own formula, which is this one, the upper one, and then the formula below here here could be used to calculate thermistor constant. This is the thermistor constant. Nah, because the thermistor constant of the thermistor is still not known yet. Later this value will be found first before proceeding to the next step by using this linear form, the linear form. This is the derivation from the formula above. Next. So this is the Arduino code that was planned to be used. Yeah, this is just mentioning the variables, and then here this one, right one below. And the below one is the calculation done from the previous formula that I have mentioned before. Yeah, I'll just explain first about this one. And the next is the experiment itself. So this is the device that has been made. This is the jumper cable, the red and the black one. The zinc selenium lens is the yellow one here, and then inside is the HBN and the thermistor. This is the aluminum foil and the aluminum foil. Yeah, the external aluminum foil and the plastic straw. This is used to vacuum the inside of the bolometer because it is said that if it's vacuum, then the thermal convection will also decrease. So it will not interrupt with the temperature measurement. Next. First, they find the beta value by measuring the the resistance produced in a certain temperature, and then they plot the graph like this. So they use the linear formula, which is I think it's down below here, left one. Yeah, and from this and from the graph, an equation is obtained. The y equals to 225.01 x plus 11.063. So as it could be seen from the formula, the beta here acts like the gradient, and this is used for the calculation later for the coding in the Arduino. As for the reference resistance, it is 63.76757 kilo ohm. So this is the resistance when it is at the reference temperature, which is room temperature at 27 degrees Celsius. Next is the resistance measurement using multimeter. This is the first phase, and it is done before putting the fabric inside the bolometer. So these are the conditions, and these are the results. Yeah, so actually it's not accurate because the results here are the same even though it's normal body temperature and cold temperature, the changes I mean. Yeah, and also the before after, and there is even no change here at the body temperature subjected to cooling. Next. For the second phase, they put the coated fabric, the HBN coated fabric, and the thermistor inside the bolometer. Then they test it in unvacuum and vacuum condition. So there are 4 types of condition which differs. The conditions differ from the conditions before. Like before there is no hot temperature, but now there is the hot temperature condition, and then the body temperature subjected to heating, but before is cooling. Yeah, and these are the resistance produced. And again, it is not accurate, and it is not a reliable result. Yeah, there is even no resistance change. Yeah, this is the experiment. Kayaknya fast forward aja nih, soalnya ini pasti lama. Just
What does it mean before and after?
Yeah, so they measure it like that. Yeah, they suspend the bolometer above the hot plate.
What is the temperature there of the hot plate? 80 degrees.
Kenapa, sir? Sorry.
80 degrees Celsius.
Yeah. This is the hot temperature at the not vacuum bolometer. Yeah, I think I'll just show one part of the experiment because it will take a long time. Next. So for the your turn, Kandi.
So for the evaluation, MWCNT as the thermistor, it has proven that the MWCNT is visible as NTC thermistor, as we already see the proof before. And for the beta measurement should be done after stitching the thermistor due to different resistance produced. Number 3, the reliable. It is the device resulting an unreliable result where the resistance changes were the same even though in different temperatures. For last one is the inconsistent conditions where result couldn't be compared due to different conditions.
Wait, I'll just explain, yeah, a bit more. So first, Kak Christo and the others had succeeded in proving that the thermistor was an NTC thermistor. It means that, yeah, the resistance will go down if the temperature increase. Yeah, this could be seen from the experiment where, yeah, where the resistance decrease upon exposure to higher temperatures and vice versa. But despite this accomplishment, there were still many flaws in the whole experiment. First is the beta value of the thermistor should be measured at least after the thermistor coated thread. The thermistor was stitched onto the HBN coated fabric and located inside the bolometer. So the beta value that I have presented to you before, it is obtained. It was obtained before the thread was even stitched to the HBN coated fabric. So yeah, there will be a different in strain and yeah other conditions that will also affect the outcome. The outcome resistance, like as we could see before, the reference resistance is around 60 kilo ohms for the one before stitching, but after stitching the reference resistance, the resistance before is around 40 kilo ohms. Yeah, so they did a mistake there. And it will be crucial because the beta value and the reference resistance will be used for the Arduino coding, and yeah, it will then affect the results. And then the unreliable results here, the resistance changes were the same, like I have shown also before, that Andi, could you go back to the table? Nah, this one for the vacuum bolometer, yeah, the D and the E and I think G, sorry, I couldn't say it is blocked with, yeah. Ini they have a 0.1 kilo ohm resistance difference, even though they are in the same condition. And also the reference resistance were not stable. Yeah, so
Hello,
yeah.
hello. What is the meaning there before and after and change?
Jadi I think the before one is before they put the kayak dideketin ke yang mau diukur. Jadi I think it could mean that it is the temperature at 27 degrees Celsius at room temperature. But then after they make the thing closer, it then change. It have a resistance change, like it could be seen from the table. Gitu. So yeah, it was not stable. I mean, the variation change is in the range of the resistance change after the temperature, after there are difference in temperature. So it will really affect the result. And then back to the slide. Nah, fourth is they test the experiments under inconsistent conditions, like the vacuum one, it is body temperature with when subjected to cold, but when the vacuum condition they use the body temperature subjected to hot temperature. Like, I mean, I think it should they should measure under the same conditions so that there will be a comparison that could be done. Yeah, and then we could also evaluate the sensor and what effect does the vacuum and the unvacuum bolometer make. Yeah, that's my opinion. Next. And for the limitations, first is the condition. They have a limit of time, and also in the pandemic condition, they couldn't do the experiment themselves. And there was also an accident where the zinc selenium lens was broken. I think they didn't mention why, but this hinders them from continuing or giving the best result for the report. Next.
As for the improvements, sensor can be positioned a quarter of the desired wavelength, which is wavelength out of 4, from the lens to the absorber in order to enhance the responsive in the mid-range, mid-infrared range. The second improvement can be we can replace the Zin selenium lens with the Fresnel lens, where it allows the mid IR range going through. It is an inexpensive, and it actually increased concentration factor due to the design of the lens. And the third improvement that can be done is to make a smaller sensor. By making a smaller sensor, smaller sensor, the absorbed IR will be less needed to change the resistance, and it will affect the sensitivity, and it will makes the sensor will be more sensitive. So the current purpose device that we will be making, so we will make a wearable active sensor, uh, where we can actually use the MWCNT COH thread that was used by previous study, or we can actually change it with thin film of MWCNT COOH. Other than that, we could add the MWCNT, such as we can add substances like PEDOT-PSS to increase the sensitivity. And lastly, we can apply AG electrodes, and it probably can increase the sensitivity, as we can see from the previous study. So for the fabric, fabric, uh, the BNPVA fabric coated could actually absorb the body heat, and this will be an important part that could help the producing reliable resistant change, because due to its great thermal conduction, and it will lead to an accurate temperature measurement.
So for the null measurement, this is the definition of null measurement. So basically, from the circuit before, or yeah,
Make it
from
quick,
the
yeah,
basic.
because we don't have much time. So actually, we're already out of time. Make it quick.
Sorry, sir.
Make
Oh,
it quick.
okay, yeah. Yeah, the change of the resistance could disrupt the stability of the whole circuit. For this method, the resistance isn't the one that will be measured. So the parameter that will be measured is the one that keeps stability in the circuit. It could either be current or voltage. So first, actually, we could use Whetstone bridge again, because the previous group, Kakristo group, haven't reached this step yet. Yeah, it measures the voltage difference, which will then be converted into resistance and then temperature. A second is by using the simple series circuit. So in simple series circuit, it follows the V equal I times R principle, where the voltage will always be stable, and if the resistance change, then the current will be the one that will keep the whole circuit stable. The current then could be plotted against the temperature, and hopefully there will be a linear line form, and from there will be an equation that could be obtained for the coding in Arduino. Next.
As for the conclusion, so MWCNT could be used as thermistor, and the results that produced by the previous study was unreliable. To improve the results, we can change the design. We can change the design, or we can change the lens with Fresnel lens, and we can make a smaller sensor in order uh, to make a better result. For the purpose device, it is a wearable active temperature sensor using MWC anti-coated thread with a modifications of BNPVA coated fabric with or the MWCNT thin film as thermistor and
Okay. Time is up. Yeah, I think make it quick. Yeah, so I think we just move forward to no more slides, right? Yeah, please next time to groups, please be mindful of time, yeah? So that you can adjust your pace of presentation, not to be too slow, like reading letter by letter. No, yeah, just do not read everything in the slide. Just put a general comment, because if it's too slow, then we really don't have much time for that. Okay, group one, please ask questions if you have questions. Please turn on your video when you ask question. Group one.
Talita and Andy, why do you use AG as the apa development further development? Yeah.
I think it may or may not be used. It will depend on the result. Yeah, we will try by using on the thread, but if the sensitivity is not sufficient, then I think we will try to use the silver electrode. This is because from the previous experiments, there are also people that use the silver electrode. Actually, I haven't read much in detail about the research paper, but I think it could be
just as the electrode or as the thermistor.
Electrode. So it will be connected to the this is the at the both ends. And I think for the fabrication, it will use the template method. Yeah.
Okay. Any other questions from group one, Ezra, Angeli?
I don't have any questions, sir.
Ezra, enough? You can ask further question.
But how about the time, sir?
Ya makanya.
Nggak usah, sir, kalau gitu.
Yeah. So okay, I just have short question again. Please, my comment is for both to be mindful of the time. What the previous students also did not do is to check if the HBN coated fabrics really increase the absorbance of infrared or not. Okay, so you have to have control sample as well, where you sew the CNT coated thread transducer onto just plain cotton fabrics and see if it absorbs infrared or not, and whether the HBN coating, the hexagonal boron nitride coating, will increase that absorbance. The hypothesis is the hexagonal boron nitride would increase the absorbance of the infrared by the cotton fabric. But is it really so or not? So please, you need to check on that. Yeah, you need to do some control experiment.
Sir, sorry, my internet connection is unstable, but you said that we have to make sure whether it does absorb, it helps absorb the infrared or not. That's what you're trying to.
Yes, because this the hypothesis of the Biomedical Instrumentation group, Christo and friends, but they haven't really proven it in any of their experiments, right?
Yeah. Okay. Noted, sir.
Okay, so yeah, my hope is that using your technique, either using the Whetstone bridge or using the current controller, that you could increase. So based on the previous result, basically they have some slight trend or sensitivity, right, towards infrared, especially when it is in vacuum bolometer, right? Only that it is too small maybe to measure.
Yeah.
Less than 1 kilo ohm.
Yeah, it's 0.1 kilo ohm.
0.1 kilo ohm, 100 ohm. Well, actually, it is large enough. Yeah, actually, you have the good circuit. You can measure that. So it's why, please, maybe the lack of the previous group is that the signal conditioning circuit, etc., is not good enough. They do not use null measurement, etc. That it cannot be properly measured. So please improve on this and do a better calibration. And finally, also, which one? I forgot. The infrared, but the circuit. Can you don't show me the thanks slide? Yeah, it doesn't give me. It blocked my inspiration to ask questions.
Sorry,
Yeah.
sorry, sir.
So yeah, the box, yeah, the volumeter box. You mentioned that you need to make it smaller. It is correct, but be careful. Like you mentioned, lambda over 4 means then where you want to measure 12 micrometer, 8 to 12 micrometer. Let's say 10 micrometer. Then you need to make the distance 2.5 micrometer, right, between the absorber and the lens, and that is very small.
Sir, but I thought we are going to make the wearable one, so I think we will not use this design. But yeah, if there's time, we could experiment with this one.
How would you make it wearable?
I think it's there will be no bolometer, there will be no casing. I think it's just simply stacking the fabric, like for there will be 3 layers. Like the first layer is the one with, and the second layer, the middle layer is the one with the thermistor, and then it is sandwiched with another cotton fabric, which is coated with HBN and BN and PVA, because it was said that the BN PVA could help absorb heat and dissipate heat to the environment. That's what I have read in the previous research. So
Okay. Yeah. What about the upper part? Is so no vacuum then?
No.
Yeah, but then it will. Then what you might be detecting is conductive temperature change or convective temperature change other than infrared radiation.
But yeah, I think we will not use the infrared one because it directly contact. But then I think there should be an encapsulation on top of the electrode. On top of the thermistor, so that it could isolate from the other environment interruption.
Yeah, but if it is not vacuumized, then you might the temperature change might be due to conduction. So conduction and convection from the surrounding air, not from the infrared radiation in front of it.
Okay, I'll try to read more. Yeah.
Yeah. You are trying to pursue something which is more difficult actually. Yeah, I mean, to prove the principle here, using their design, their bolometer design, is maybe straightforward. They have already the qualitative proof that it might be detecting the infrared, only now not sensitive enough, right? So you just need to make it more sensitive for now. Vacuuming, but so changing the lens for now, yeah. Not yet truly wearable, but something. So the novelty also quite good because you have now the infrared absorber is cotton, thermistor is anti-coated thread. Only you change it to Fresnel lens, but you still make it small bolometer. But maybe you cannot make it very small because to have a cavity of 2.5 micrometer between the lens and the absorber is very difficult, right? Because lambda over 4, you mentioned lambda over 4. Yeah, between the lens and the absorber. If you want to measure bit infrared, which is 10 to 8 to 12 micrometer, let's say the median is 10 micrometer, then you need to make the distance 2.5 micrometer, which is basically almost no gaps. Yeah, very difficult to do it in macro scale actually.
Yeah.
You use micro technology. For now, it's not easy. It's not easy. So unless if you can find some incredibly brilliant idea.
Okay. Yeah, I'll try to
Okay.
search for
So
that.
yeah, if you want to make it like you said, irreversible, then it will not be from radiation mostly. It will come also. It will be affected also by convection and conduction of the surrounding air, not only by the radiation. Why they make it vacuum? Because so that it is only sensitive towards the infrared coming from the front of the lens. So not sensitive anymore towards the surrounding air temperature. So you
So,
understand?
but if it's through conduction or convection, should it be still vacuum or kayak
Yeah, no, if it is conduction convection, you don't need vacuum anymore.
yeah,
Yeah.
because I think that's what I'm thinking, kayak kita buatnya kayak naruh aja gitu, not di infrared.
Yeah, but then it is just become like touch sensor, touch temperature,
Oh, okay.
touch
So
touch thermometer, right? No, not much difference than that.
but with cotton fabric gitu
Yes,
aja sih.
yes, yes. That's all. If you can you want to proceed it first that way, yeah, it's okay. Then if possible later towards the more challenging infrared thermometer. Yeah, which is no contact infrared thermometer. Okay.
Thank you, sir, for the feedback.
So please, everyone, make your report according to the feedback, and please write the report and submit it tomorrow. And next time, please do presentation, make it quicker. Yeah, mind the time because actually today is only 2 hours. You don't have class from 12 to 1. No class, yeah. Okay, thank you.
Okay.
Yeah.